So the first case study here, let's start with where your corn hits the water, right? So at this facility, the density meter will occasionally go flat, like just stop moving, right? And meanwhile, at the same time, the cooked solids were visibly changing. And the meter had silently faded, but nobody knew because the number on the screen looked fine. So for 148,000 gallons per day, every hour of that silent failure of off-spec feed walking straight into your fermenter made it worse because your mash consistency is off now, and what you're expecting as your yield output is never going to be the same. And this problem gets further worse with the seasonal variability. The density target that works in October will not hold up in February, as we all know. But without a system watching whether the density, the slurry density or the lick density and your cooked solids are tracking together, not just whether the number looks right on the screen, but actually if they are moving in the right correlation or not, that drift doesn't show up until your yield drops the days later. And that is what we saw at this facility. Their cooked solids and their slurry density often on these red zones will detach from each other, and there will be variability in their mash. So what did we do for this problem? We enabled our, I should say, commissioned our early warning system that watched this slurry density and the cooked solids and whether they are tracking together or not. When they stopped tracking, it fired roughly an hour before. Bad feed will hit fermentation in 60 minutes if you don't flush your density meter. And that was the kind of like an early warning which goes out on as an email or as a in-app notification to the operators so they can go either flush the density meter, correct it, and move on. Just with that alone intervention, the yield was up by 1.08%. That's almost 0.034 gallons per bushel. And at the throughput of this facility, that's almost 605,000 gallons per year. With the rough math, that's 1.6 million annual revenue just from catching a broken meter an hour earlier. So this case study was all about, you watch the relationship, not just the empirical value which the DCS puts up in the control room. And when you watch that relationship, and if that relationship gets broken, using our early warning system, we were able to catch that, feed quality failures, we call it, 45 to 60 minutes earlier, that was giving consistent results to the fermenters in the feed, in the mash consistency, and producing higher gallons per bushel. Going from slurry to prop here,